everyone. Welcome to the Cloud Data Protection for 2022 Summit. Today's event was organized by the hardworking folks at Redmond Magazine, Virtualization and Cloud Review, and AWS Insider, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Rubrik, the Zero Trust data management company, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of two information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, Rubrik, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And last but not least, at the end of the second session, one lucky attendee will be receiving an iPad Pro with the new M1 chip. But you must be present to win, so stick with us. Now let's get started with our first session, Top Threats to Your Cloud Landscape in 2022. For this session, we've called on Ian Thornton-Trump, Chief Information Security Officer at Cyjax. Ian is an ITIL certified information technology professional with 25 years experience in IT and cybersecurity. He served in the military intelligence branch of the Canadian Forces, the Canadian Forces Military Police, and the RCMP, where he was a criminal intelligence analyst. His experience and ongoing research have made him a sought-after cybersecurity consultant for multinational insurance, banking, and regional healthcare organizations. Ian also teaches cybersecurity and IT business courses as a member of the Computing Technology Industry Association's global faculty. And he's the lead architect for CyberTitan, Canada's effort to encourage the next generation of cyber professionals. You are in for a great session. Take it away, Ian.
Hey, thank you so much, John. I'm really delighted to be here on this one because I get to cast a bit of an eye based on what has happened in 2021 at the future of cloud. And, obviously, cloud security was a smashing success in 2021. Not really. And it seems like the overall trend is going to see a lot more hostile activity directed towards your cloud. But just to give you a bit of a background, I am indeed the CISO of Cyjax Limited UK, working in the threat intel space, which I will bleed a little bit of that threat intel data that we have into this presentation. I believe there's also some collateral available in your downloads that I've supplied as well. And I'm also a CTO of a managed services company, which obviously was in the news pretty heavily as a result of the revelation that the hacking group responsible for the SolarWinds supply chain compromise was indeed targeting MSPs. Not that we have been targeted, but I understand many of my brethren have. So very, very timely presentation with some up-to-the-minute data, I would call it. So, one of the assumptions that we can really make about 2021 is we saw a rapid digital transformation, in some cases, digital transformation at any cost to survive the pandemic. What I think is going to happen is we're going to see the massive movement and the continued massive movement of applications into the cloud. That train doesn't seem to be stopping. I think, though, what's interesting to me is that every sort of 3 to 5 years as leases expire, there's a moment that can be seized to look at accelerating digital transformation and movement into somebody else's tin rather than forking out for more hardware. So I do see that this trend will continue as lifecycle management of the actual hardware infrastructure and that space that is usually expensive from the HVAC, heating and air conditioning perspective, becomes reallocated to other business operations and even office space. So we see this trend. But, in the wake of that trend, it's not surprising to see cyber criminals and APT groups attacking and exploiting cloud infrastructure for their own purposes. And those purposes are diverse. Some of it is crypto mining, some of it is ransomware, and indeed some of it is intellectual property theft. So one of the sort of buzzwords that's really come into its own right now, I'm going to kind of take a bit of a segue and go down this road with you, is that everything is actually a supply chain attack, okay? Like, unless you're building your own operating system, you are subject to the vulnerabilities of that operating system, which you bought from Microsoft or Apple or Android, whoever, right? So what I found interesting is that the definition of supply chain is a bit of the bleeding obvious. And I'd like to sort of change the paradigm a little bit and have supply chain include not just all the products and services that you buy to run your business, but also those partners that supply those things and your customers who supply you with money for the services and the products that you build. So really what we're talking about when we say the word supply chain, is we're actually talking about the entire IT ecosystem of vendors and, the customers and the manufacturers. And so nothing has really changed, except one thing is that we've now sort of taken this and given it a life of its own, similar to the idea of zero trust. And don't even get me started on zero trust. I got to stay focused on the cloud. But to be fair, when you think about, the supply chain of attacks, we go all the way back into 2015 and look at APT Cloud Hopper, which was a Chinese APT group that exploited MSPs for access into the customers of those MSPs networks, including some big global MSPs got hammered in 2015, right? That's one type of, quote, supply chain attack where, a business partner is compromised and then that compromise allows lateral movement into, customer networks, right? Fast forward, that's exactly what Microsoft was calling out in the last couple of weeks. So really, situation, no change, and happens a lot. But when I dug into this a little bit more about the idea of taking a benign or a piece of software and polluting it with malware and distributing it, we go way back in time. So this threat model, the one that caught Kaseya, the one that caught SolarWinds, the one that created NotPetya, which was based on an accounting program that was put on a server in the Ukraine and then downloaded by a whole bunch of customers. This goes back to some ShadowPad group hacks about almost 4 or 5 years ago now, where CC Cleaner had malware inserted it, and now it's owned by Avast, but before, I think it was just on its own before they purchased it. And it, in fact, contained malware that was used in attacks as well. So the idea of we got to secure the supply chain, we got to focus on the supply chain, that is, I think, some marketing FUD that is going to get you wrapped around the axle if you don't stay focused on the overall ecosystem and the overall cybersecurity environment that you're on. So let's talk a little bit about the cloud attack surface, because in order to really think about the future of what we're doing, we really need to think about what's in the cloud, why organizations are going to the cloud, and it's essentially to deliver applications. That is sort of the number one reason why we're using cloud. Now, there's other reasons that we do, like data pools and data lakes and storage buckets, etc. But the idea is that you could build and do things like rapidly prototype applications into the cloud space, and you would have it running in a highly redundant, monitored, SOC 2 compliant environment, right? So the attack surface of your applications running in the cloud is all of the OWASP 10, right? We just had the new OWASP 10 release, and some of the old stuff is now the new stuff, and some of the new stuff is now the old stuff. But the reality is that the application attack surface is the most likely thing that you're going to get a hit. as well as those APIs that may or may not be exposed. In descending order now, we have the security on storage buckets. This is a huge thing. In this webinar, we're going to go in and we're going to look at that situation and why it needs some careful attention and why actually it's disincentivized. And we'll talk about incentivizing security in a bit as well. I really see access control lists being underutilized in this space and poorly configured security groups. I get a lot of answers about, oh, well, don't worry about that. The access for those users is in a security group. That's great. Unfortunately, the problem is if there's a vulnerability in the service that's being exposed, even though it's protected by a security group, you don't have an access list in front of it, and therefore anyone that can find and enumerate that vulnerability in like an old SSH daemon, all of a sudden can own your boxes. And then, of course, the fun ensues with lateral movement using something like MCATs or something else, MIMCATs, or something else that enumerates a privileged user with inside. So I see that either folks focus on access control lists, which is good, or security groups. I'm saying work with the two of them. And then the actual application itself has to have a bunch of other dependencies in order to run. That could be the repository, the code repository, the rendering applications. By that, I mean something like PHP or Apache, the CMS, the content management system, the backend database, the operating system itself, if you're not running in a services environment and you're running more along, discrete boxes that are performing those different functions. In some cases, the hypervisor OS may have a vulnerability. We have seen in the past a few breakouts from the hypervisor or from virtual machines into the hypervisor, et cetera, et cetera. And then, of course, there's the hardware and firmware and BIOS, and back-end switching and all of that kind of stuff, which is generally the domain of the hosting provider and not your particular implementation. So, okay, I'm going to get a bit of controversy on this one because I don't believe that you should be pen testing nor vulnerability scanning in production. And I know, but hear me out on this. One of the problems that we have right now is that if you are taking all of these free tools that are used to enumerate and scan, and you start applying them into your hosted production environment, you run the risk of two things. One, unanticipated downtime of your application. Now, that might not be a big deal if you can schedule it accordingly and you can tell the business that there is a small chance that our app is going to fall over when we hit it with a vulnerability scanner. Fair enough. But if you're highly transactional, that this system backends into electronic data interfaces and possibly into a number of systems, you may impact the business severely, okay? Because freezing one electronic data interface, which takes orders from a shopping system that you might have online, like with carts and stuff, that could impact your business tremendously, especially at peak times during all of those Cyber Mondays and Black Friday sales and things like this. So I believe that if your dev environment replicates your production environment, that's where you should do the majority of your vulnerability testing and scanning. I'm pretty sure we're going to get into a fight about this, and I'll tell you how we can fight that a little bit later. But I also want you to realize that these tools, these free tools that are available on the internet, of course, can be used to secure your productions environments, or can secure your development environments before the push into production. But also understand that sophisticated tools are certainly in the hands of malicious evildoers. And it's difficult to tune other pieces of your security apparatus when you're hitting it with what essentially looks like hostile activity. And we'll talk a little bit about that as well. So this was the big news that broke out a little while ago. I know this is a bit text heavy, but I kind of want to run down this again. So it's clearly that Microsoft is sucked up on the whole supply chain thing like that. But and of course, we're calling APT28 by a new name now. We seem to reinvent a name every time that there's a different hack. But this also, I think, is an issue with the fact that the cyber attackers are using obfuscation as part of their OPSEC. So we're not sometimes really 100% sure. And people come and go within those APT groups fairly often. So I see this sort of as a constant sort of battle of trying to lock down exactly who this group from the FSB were. And if you've ever happened to follow any sort of military stuff in, like, you know, the United States military or any of the other G20 country militaries, what they were calling something today frequently changes, if you want to call it a military rebrand per se. But, you know, the project that you were working on for several months is now a new project called the same. So I don't know if this is to, you know, obfuscate exactly all of the different things that are going on within that dynamic. But understand that there is some obfuscation going on. But I think this is really important because this APT28 group, you know, arguably the one responsible for the SolarWinds attack, really set a new stage in the audacity of that particular attack, okay? And then ENSA comes out and basically says that, you know, and confirming what I sort of already figured out, was that attacks against cloud infrastructure will almost certainly continue and will likely have greater impact, right? So we're trying to see this as well from the perspective of the cyber actor involved. And the ENSA report, if you don't have a copy of it already, blew my mind. I would call it even more granular than the Verizon data breach report, which is probably one of the gold standards in threat intel for understanding, you know, the changes in aggressive behavior on cyber and cyber attackers. ENSA actually includes a ton of great data on mitigating these threats, and not just the standard thing of, you know, back your files up type of thing. So I was really quite impressed with the level of detail in this particular report. It just came out about a week ago. And it's really focused on the criminal element, right? And especially, and this is why I put Rubrik's note down there, is because of the idea that getting you to pay ransomware is clearly focused, a ransom is clearly focused on your inability to recover, okay? And this is why, you know, one of my top things for 2022 to mitigate attacks is get on top of those disaster recovery. And, you know, woe to anyone that thinks that, well, we can just push from dev back into production if production is taken out by the bad guys. You're assuming that the bad guys haven't gotten at your dev environment as well. Okay, so you absolutely need, you know, what's better than a backup? A second backup, right? Because you need to anticipate the fact that if the bad guys have gotten into your production environment, there's a good chance that they're able to laterally move into the development environment and or onto the workstations and servers of your on-premise infrastructure. So assume compromise and make sure that you have a backup plan, because one of the first things these guys go after is ripping apart your infrastructure only after they've sabotaged your backups as well. And we all bless and remember TimeHop, and cloud, it was Cloud Spaces that got totally obliterated by bad guys that did just that, and completely nuked them, and the company went under as a result. One of the rarities actually in cyber security where impactful cyber attack completely erased a company from the internet. Not good, and something to be aware of. And now this is the one that I think where this is a moment where we can take away, and you know, the true threat intel is really about hearing somebody else that got pounded by a cyber attack. But this one is, I think, really interesting, is that Microsoft, according to what their sort of recent campaign by those APT28 hackers, didn't attempt to exploit a flaw or vulnerability in software, but rather used well-known techniques like password spray and phishing to steal legitimate credentials to gain privileged access, okay? So what does this really mean? It means that this was not a particularly high-level, highly sophisticated cyber attack, and that APTs don't necessarily develop a complete set of custom malware and zero-day exploits when a known attack vector is still proven to be an effective way of getting into the organization. Now, there is some hope, especially with some breaking news that happened yesterday that one particular ransomware group, I think it was the Hello Kitty crew, they have added the third level of blackmail towards an organization. So not only do they steal your data, and then they threaten to publicly release it, they also will DDoS your organization. Okay, so 3 different ways to coerce ransom out of you. The cloud has solved the DDoS issue more or less. Okay, in fact, in the last little while, we've seen huge beatdowns from the providers, Amazon and Azure, against these giant bot networks, 70,000 in the case of the one that smashed into the Azure cloud and tried to take out a customer of Microsoft's, that they managed to mitigate. So one of the things that I've been telling a lot of people, and this was sort of maybe the counterintuitive way of exploring one of the primary reasons of moving to cloud data as opposed to on-premise, is generally DDoS protection for on-premise is going to be expensive, and it may not be enough, okay? Whereas you get it for free in the cloud, okay? So it seems to be the only free thing in the cloud, and it makes sense because, if you can't use the cloud infrastructure that you purchased, then that's sort of like almost a trespass like chattels moment, and you can expect the providers to react against that. This is also where testing things like stress testing production builds is an absolutely terrible idea, because a stress test of a production build looks an awful lot like a DDoS. And this is a great way to get your own IP address from your corporate network blacklisted. Okay, so please don't do that. This is why, again, I advocate for having the dev environment an exact replica, and we can get to that because I'm sure somebody's going to bring up this question. But the idea that your dev environment is where you can do your stress testing, right, and then you can push that into production when you see that the build is okay. I think a lot of this stuff in sort of the next iteration of cloud and application builds in the cloud is going to be part of a QA tool suite in order to make sure that, you have a smoke test, you have some basic user functionality tests. But I think part of this is code scanning and basically some security sanity checks. It's going to start becoming a QA role combined with actual DevSecOps in more of a reactionary role. So proactive security for your cloud applications begins to become a QA responsibility. Reactive security for the functioning of those applications becomes a DevSecOps responsibility. So, right, threat intel. Okay, so I'm going to share with you some stuff here on some known actors and how they attack the cloud. And this is exactly why we need to talk about threat models. We need to understand the difference between, on-premise defense, in-depth posture, and the cloud, where literally everything, including the exfiltration of your data, can happen at cloud speed and may not even be noticeable if you don't have the proper tools deployed, right? So what we're seeing is a bunch of different types of usage of your cloud infrastructure should the bad guys get to it. Okay, so the first one is cryptocurrency mining from the Rogue crew. Now, this one is a little bit interesting because they are targeting a lot of known vulnerabilities. And what was surprising is, of course, Apache Struts, Adobe Cold Fusion, people sometimes still use that, right? PHP, MyAdmin, and Redis was a little bit weird because that seemed to fall outside of the sort of very traditional attack surface. So not exactly sure. But these folks are just basically trying to use your infrastructure to mine as much crypto as they can. If they gain access, a lot of the times they'll do it over a long weekend. They'll stand up tons of servers in your environment, mine the crap out of that they can, and then they clean house, clear it all out by by Monday or Tuesday when everybody comes back to work. That is part of the toolkit. Given the high price of cryptocurrencies that just seem to be going up and up and up, I expect in 2022 to see more cloud infrastructure compromises where cryptocurrency was the primary vector of attack. Now, fancy bears, everybody loves bears. Again, like look at this, fancy bear, APT28, strontium, nobelium. I think there's even a case that calls these guys by a bunch of different other names as well, way back in the day, Turla being one, et cetera, et cetera. So these folks are doing essentially thuggish types of attacks, but if you dig into some of the APT28 toolkits and some of the things that they've unleashed, some of it is pretty sophisticated. So the part where initial access was gained into the network of SolarWinds, and then that malware got deployed by Microsoft, and then Microsoft noticed follow-on attacks. This follow-on attack and access to Office 365, for instance, was granted by the creation of a golden token, which exploited a Kerberos vulnerability in order to gain access to those Office 365 accounts, which eventually led to the compromising of a bunch of district attorneys and the U.S. Justice Department's access to the public access to court records system. Okay? Now, that is a long line of stuff. Now, do you remember back when all of this was happening, Microsoft's president in congressional testimony said they believed that there could have been up to 1,000, he said hackers, I would say offensive cyber operators, but there was maybe 1,000. This is because they're going to work in different teams with different objectives, okay? This is not a smash and grab crew. These folks are experts at what they do, but they're very narrow in what their responsibilities are. Just like when we analyze the NSA and their capabilities, they have some folks that build, and exploitation. They have folks that do initial access. They have an espionage capability once initial access to that targeted host network is established. It's all broken up with handoffs, et cetera, and I'm sure there's some, project managers involved there as well. These are massive organizations with everything from the lowest denominator type of attack to highly sophisticated zero-day malware. So you need to keep that in mind in the threat model, that just because you're seeing brute force attempts doesn't necessarily mean that they haven't gotten in, right? The other two interesting folks is Team TNT, which we have intel that suggests that they're German-speaking, which is kind of interesting in itself, as you don't see many cyber criminal groups operating in Germany. However, these folks are really around finding misconfigured and publicly exposed cloud instances, right, in Docker, Kubernetes, and Amazon Web Service as well. And then, another crypto mining outfit, this time a Chinese-speaking group that is that goes after a bunch of variety of different internet-facing servers, specializing in what appears to be CMS like Drupal exploitation. So all of this stuff really comes back into what I like to call a high-level threat model against your cloud infrastructure. And so based on these four actors, what are the most probable things that are going to get hit with, right? So remote code execution vulnerabilities in anything from the hypervisor on up, right? So operating system, like rendering apps, the CMS, the actual application code that you're running, some of it custom, maybe some of it a plugin, et cetera, or library exploitations as well. So remote code execution vulnerabilities, brute force credential attacks, right? Like that's what, APT 28 seems to at least start off with before they hit you with something heavy. Misconfigured servers and services, right? So all of this is because Azure, Google, and Amazon all have different approaches to doing things, and it can become a very complicated environment when working at scale. All right, and the vulnerability of your internet-facing servers, and that should be applications. Okay, so the questions then, if we've constructed this high-level threat model of like 2021/2022 and beyond, right? What you need to ask yourself is, what tools do we have that we can detect these style of attacks? Because if these are the top attacks that the bad guys are using against you, you'll want to detect that they're happening. And then the questions are, can you reduce your attack surface? Can you remove that vector of attack with certain pieces of software and or techniques, right? And then, of course, I always like to say, do you have a cyber threat intelligence program tracking these attacks against other organizations, right? So if APT 28 is running around on the internet and they're, for instance, exploiting something like a VPN provider, right? You'll want to know that that particular VPN is falling victim to a zero-day or an enumeration attack for credentials, right? Which happened to SonicWall, happened to Pulse, secure VPN, not secure until you patch it, right? So when you look at the threat models that are there, it's pretty easy to construct, what you need in terms of defense, right? So this is where I'm going to get a little bit controversial on you, because it is essentially the number one crowd problem, as I see it, is you don't know what you're doing. You don't or didn't budget for the cloud security tools you need to detect things that are going to happen in the threat model. Your PMO has never executed a digital transformation project before. This is a problem, right? Because as soon as the organization says the words digital transformation project, the CISO or the head of IT security needs to jump in there and say, hey, man, I need to be at those meetings because there's going to be some security considerations and things that I might need to budget for, right? Project management office, PMOs, are the ones who control the keys to financial kingdom. And if they have to put in a request for, an overage because somebody forgot about log management for all of this fancy cloud stuff that you're going to build, you have to get in front of that bus before, a year later when compliance is doing an audit and saying, okay, so what's the logging looking like for this system that contains sensitive information? And everybody just sits around going, yeah, that wasn't part of the project requirements. That's a huge problem that I see in a lot of cases, because if you don't budget for these things, then it's really difficult to retroactively add them when you've spent all the money that there has been on high-priced consultants, right? So one of the things that inevitably ends up happening, and I put this in red, is that security starts getting disabled in order to make the application stack work. So not only do you potentially have a vulnerability there, you don't even know about it anymore, and because you're not capturing the log data or having a SIM there, all of a sudden now you're flying blind as well. So you didn't even know whether or not your application is healthy and hasn't been taken over by bad guys until the worst thing happens, right? So when I really talk about this, it's like this is sort of the combination of finding the tools that you need to address the risks in that threat model, but also starting and trying to, we say the term bake in security, but really talk about how you're going to manage that landscape appropriately and making sure that the security is built in from the start and that the tools are there and that the team understands what's going on. So we'll talk a little bit about that in a bit as well. So this is where bad things happen, and I talked about the security on S3 buckets of getting basically degraded or accidentally made public. So let's rewind to really early stages in Amazon hosting, where it was very difficult to determine whether or not an S3 budget was public or not. Now, they have made it excruciating with warnings in order to try and persuade people to spend the extra amount of time securing that infrastructure, because what they are really getting hit with now is all of a sudden, Bob Dijenko or this group, Grey Hat Warfare, has publicly indexed those buckets of data that may not even be yours. So a great example was, I was working at a large financial institution. I plugged in our financial institution's information in Grey Hat Warfare, and I found a bunch of invoices from a contractor that does work for our particular company, right? Now, in all the T's and C's of our relationships with contractors is a requirement to keep our data secure. Well, you can imagine I'm in a regulated environment over here in the UK and EU, and having hundreds of our company's invoices with the signatures of purchase orders, with addresses of our different facilities and everything like that, names of people, certain activity that has taken place that could be exploited by cyber criminals, right? All of that was publicly available, right? So I had to get head of procurement and talk to them and try and get a hold of their IT person who really didn't want to take a phone call from me. I'll say that. Sometimes not everyone's a fan. I'll give you that. But anyways, there was a huge example of finding our company's data related to us in a third party that had a fiduciary responsibility to keep that data sensitive. Now, why is this such a big deal, and why am I losing so much sweat over it? Because this data is collected, then it's sold on the dark web to cyber criminals to conduct fraud against your organization. Legitimate invoices are being essentially given out back to customers. It's been pandemic for 2 years. There's been a breakdown in communication against your organization. The fraud is, here's this invoice dated, from 19 or 18 months ago. I know we've been through the pandemic. It remains unpaid. Can you please send us a check right away? Or, we're going to take you to court. We're barely surviving. This is such a huge scam that we're seeing here in the UK right now, where invoices for, 1,000 to 3,500 quid are like, I'm sorry about that. There's been some changes in the organization. It was the pandemic. I guess something slipped through the cracks, and they're paying it, right? So keep this in mind, that when you find third-party sensitive information, or even that you've exposed information, it can all be monetized by the cyber criminals and used against you. I recommend getting a subscription to Grey Hat Warfare and querying it, once a month, once a quarter, to see if either you've had some sort of data exposure within your own organization where security misconfiguration has taken place, right? Because keep in mind, security's role is to try and keep the organization secure. IT's role is to try and deliver the projects that they need to deliver on the excruciatingly tight, high-stress timelines. So they might not even make an intentional mistake. They just might make an accidental mistake, and therefore suddenly you're finding that this bucket has been exposed, and now you can work with them to kind of close that up. So this is a great proactive way of approaching the problem. So as we start winding down a little bit, we're going to have about 10 minutes more, 10 to 15 minutes more of me ranting. I want to talk about the future and about how I see DevOps merging into DevSecOps, backed up by a cyber threat intelligence program. This is so, I think, important at reducing the amount of silos in your organization between security responsibility, right, and the actual functioning of the IT department. Because I say this with all due respect to the managed service providers out there, IT is security, and security needs to be IT. okay? And compliance can sit over top because, to be fair, the evidence of security is what compliance is concerned about, okay? So when you look at that and you say to yourself, well, listen, IT is now becoming part of the function of the security team and vice versa. We need to work more collaboratively, and the best way to do that is to combine the operational, is it running, is it performing properly, is it available in the system, with is the information confidential, does the system have integrity, is the information being kept confidential, does the system have integrity. This is a huge transformational thing, I think, in organizations that really fits well with an agile methodology in order to try and marry the two together at the sharpest end of the stick, which is usually the cloud-based applications that are generating the revenue or providing the service for the organization, right? The number one rule of this is if the application is poorly architected or is vulnerable, the platform on which it is sitting is irrelevant. Okay, this is really important because if you don't have any compensating controls, right, such as, and we'll go into them a little bit more in a bit, but if you don't have compensating security controls deployed, chances are that the vulnerable application or operating system or hypervisor will come under attack, right? The big one right now, I think, is really getting comfortable with the cloud environment. That's why I said, if you're involved in digital transformation projects, the earlier you can get to and beg, borrow, and steal money from the project to get your folks certified on those particular cloud environments that you potentially are using, okay? It's a big ask. But if you don't understand something, like we used to say in cybersecurity, if you don't know that it's there, you can't secure it. But if you know that it's there and you have no understanding of what it is or how it works, how can you be expected to secure it, right? So there's a double-edged sword coming at any IT or security department if they don't have the knowledge base and are not early at the table to make sure they understand what's happening. Now, this is the other one where I said, don't test in prod. Ensure your staging and perhaps development environments are as close to the scaled versions of a production environment. I have seen situations where the dev environment uses a shared database server with production. That's a no-no, okay, without data sanitization. Okay, terrible, easy way. And that the dev environment is sitting on one box while production is like 10 or 15 boxes or even more. That's also a terrible idea because of something called inter-process communication, where different functions running on the box will use inter-process communication as opposed to having to reach across the network and connect via API. And one of the things that we're always talking about is we need to encrypt data in transit. So what do? We roll out TLS. And then all of a sudden, because the development environment is sitting on one box and is patched appropriately, but there's a bunch of boxes in production that aren't patched and updated appropriately, your application starts breaking. I've been there and saw this firsthand, and it took a while to run down because everything needed to get to the same patch level. And keep in mind that some patches, especially for .NET, you cannot uninstall them. So again, very dangerous if all of a sudden, you've made something work with one layer of patch, you've added new patches, it stops working, you're under a tight deadline, and you're trying to figure out how to roll back a .NET security update, and you find that you can't. You're now restoring that box from backup, right? Now, it's not as dramatic as it sounds in the cloud environment because hopefully you're using snapshot technology and something to manage your instances and backup, like our sponsor, but it still is a bit disconcerting when you find that you applied the patch thinking it would fix it and it's actually broken something else. I've harped on this enough, but encrypt that data at rest and encrypt it in transit and store secrets safely. It's super important. And I think our next presenter is going to get into some of the best practices around those things as well, so I won't steal too much of her thunder. So some of the top tips that I look at as being is being really important. Is, of course, looking at, is it appropriate to deploy content delivery network? I always think you should have a Windows application firewall deployed in front, especially even if it's after the load balancer, but before it hits the front end. Ensure your threat actors are included with your threat models and form part of your CTI program. Right? Knowing what these bad guys are up to becomes super important to manage your expectations in terms of, are we going to be able to detect these attacks? What's our mitigative strategy, right? Big one is the multi-factor access controls. I won't talk about specifically where those should be found in the organization, but let me just say that these controls are very effective in stopping some of the TTPs that the bad guys will use. Integrity monitoring and vulnerability scanning of your infrastructure is super important. I believe that if you secure your development environment as you would production, storage buckets, and blobs especially, you will be in a much better state, and you'll have something that resembles the production environment for that critical testing and or vulnerability scanning and management. Obfuscate the data in the development environment for sure. Like, nobody should be tapping into production data in a development environment. Not only is it a bad practice, but it's a good way to get your data stolen. And of course, DR/BCP testing, and consider multi-region deployment for major apps. So takeaways, intellectual exercise, if you will. Some people used to call it homework. Please download and read the analysis report, AR20 268 Alpha, the federal agency compromised by malicious cyber actors. This forms probably one of the most insightful analyses of a cyber attack on a large government agency and all the different things that kind of happened within that environment, that until they discovered that there was a problem, they had no idea it was going on. So this is where I really think that we're headed, is that getting the logs and data into a SIEM from cloud-based applications becomes super important, and ensuring that that SIEM has an optimal signal-to-noise ratio is, I think, the biggest problem that we face right now, right? Which is that information overload. But what I can say is I think there's hope on the horizon, okay? So one of the major contributions to Defender capability has been MITRE ATT&CK. This is something you really want to look into. I connected a link for the MITRE ATT&CK matrix for cloud applications specifically. This is super important because I think our future lies in getting away from SIEM risk scoring, okay, and looking at the ability to try and determine if activity within your environment fits the profile of a threat actor, so to reduce the amount of false positives. I always like to say things like, nobody should be scheduling a task on any box without a service ticket as reference, so that if your SIEM detects that a scheduled task has been deployed onto a box or a cron job created, then that's something that should be a smoking gun if you can't find a reference to it within your service management system. So I see that applying machine learning and AI based on mapping all of those threats, and that's why I had you suggest that you read this, you read the previous slide in depth, because they break out each of the aggressor's actions into a MITRE ATT&CK framework. And this is where I think the golden bullet will start arriving for securing cloud infrastructure, is to map threat actors to those MITRE ATT&CK activities and giving you a probability rather than a risk. And this is where I want to see and hope that the industry evolves into developing more accurate information that can then be fed into a next generation piece of equipment such as a SOAR solution, and take immediate action, whatever that action could be. It can even be things like burn the box and and then kick off orchestration to bring the capability or service back to life on a fresh instance. So there's lots of things I think coming at you in the future, and I'm now going to kind of stand by and open it up to any questions you might have around the last stuff that I've said.
Thanks, Ian. I promised them an information-packed session, and man, you delivered. So let's get to some of these questions. The first question we've got here is from Kareem. And is a hybrid environment the answer to avoid being compromised by cyber criminals in the cloud?
So I did a thing on hybrid environments, and really where it comes down to is what is the resource picture of your organization in terms of can you support both the on-premise and cloud? Do you have the capabilities and the security visibilities? I think that hybrid is an excellent idea, especially if you want to pry out some value from the tin that you have sitting in your data center and you want to be able to scale up to meet demand. I think it does have some applications. But I go back to Bruce Schneier. He said in 2005 that the enemy of security is complexity. And so if you know what you're doing, I think you can really build an amazing, capable, and robust system in the hybrid environment. But again, it is the comfort level of the CISO and the security team and the IT team. Because I know a lot of IT teams that get blindsided by digital transformation. And this really was a huge trend that we felt during the pandemic, where all of a sudden, wait a minute, I'm a Cisco certified engineer, and you're asking me to try and reconfigure a BT router's DNS so that it can support a VPN tunnel. It's like, you've got this really high-priced engineer pulling their hair out on how to make it. Turns out, long story short, you can't change the DNS in your BT router. So you have to go local hosts file, which is a short-term solution, but man, it don't scale very well now, does
it? Listen, I just want to remind everybody, you can type your questions into the Q&A box anytime. We'll do our best to get to all of them. Let's get to the next one here. This is from Beverly. She's asking, she says, I have a cloud team and want some ideas around budget for 2022. What are your thoughts on investment based on the awesome presentation you just gave?
Well, okay, I like that, right? So, so if I had to choose, I would make sure that my people knew what they were doing, right? And that I worked with dev and QA and tried to make the applications that are going up onto my cloud platforms as robust and tested as possible before they get deployed in production. So that's the first one. The second thing is if there's any vulnerable systems that are part of, so say because of a particular business requirement, you've got to run an older version of Red Hat or, God forbid, a 2008 server, work with the IT team to lifecycle manage those boxes or work with the business owner to ask what the roadmap for that is. And third, get that logging and SIM deployed and under control. And, work at it slowly, like add apps and a bunch of servers, tune. Add apps and a bunch of servers and tune. Don't try and just say, yeah, man, just open the floodgates. We'll suck it all into them, because literally your head will explode. I know one organization. Oh, and then the one final tip. Don't let the organization use your SIM as a log management solution. I worked for one giant bank who was trying to consume 13 terabytes a day in logging into QRadar, and QRadar just exploded, right? So, so again, think about, and focus that life cycle, the secure software development life cycle, right? the IT roadmap of getting rid of the vulnerable that might be present in your cloud infrastructure and getting logging and SIM under control. And then just put your feet back and chill out, because life will be so easy. Okay, maybe not.
So here's another one. Shamsur asks, what regulatory actions in progress are in progress, I assume, to ban cyber attacks worldwide?
There is a ton of activity coming out of the United States. Europe and whatnot, Europol is going on a tear right now. Here in the UK, Ofcom, who has the responsibility for managing internet and communications, is spooling up anti-fraud and anti-cyber criminal activity. I think what we're going to see in 2022 is a much higher level assertiveness from especially the United States, who seem to be in the role of the global cybersecurity police these days. However, I think from the massive success that Europe just had, for instance, going after over 100 cyber fraudsters in Germany, that was a sort of a key moment where you sat back and went, wow, somebody's getting into the game. You know, another player has entered the game. So I think there's a lot more effort, a lot more focus as well.
Okay, we've got time for one more. This is from, and hope you, Teddy, will pardon my pronunciation, Videhi. Excellent presentation. As banks pursue digital transformation, what are the challenges they face? What should we consider?
Yeah, crypto is where banks are headed, right? Like, the idea of the application of the blockchain is what is on the minds of most of the banks. But again, you know, it's interesting because I would say if I was working for a big financial services institution, I would want, from a cybersecurity perspective, to educate myself on the challenges of working with blockchain, security questions, you know, what internal safeguards do we have against fraud and bad actors? Because what typically happens, right, is we implement a technology. It opens up this whole new attack surface for, you know, cyber criminals to use, 5G, right? And now I'm going to hack you from my Tesla that's 5G enabled. So I think that where we need to go is really down that education. So if you have an architect, someone that has an interest in crypto, I'd start getting them into the meetings so they can understand what the business is trying to achieve. Because where I see this all falling apart is if you're not in those early stages of understanding what the business wants to do from an IT perspective, then you're going to build them something that looks like a donkey, even though they've asked for a pony, right? It gets lost in translation a lot. So get into those meetings, learn what you can about crypto and blockchain, and then start researching on how are we doing this securely, and what firms are sort of leading the charge.
Well, it looks like that's all the questions we have time for this session. Thanks, Ian, for an awesome presentation. Really appreciate it.
You got it.
Welcome back to our second session. David, please take it away.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers and to John K. Waters for moderating the first session, and, of course, Rubrik for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called Modern Cloud Data Protection Best Practices. Our speaker for this session is Karen Lopez, Senior Project Manager and Architect at InfoAdvisors. Karen has 20-plus years of experience in project and data management on large multi-project programs and specializes in the practical application of data management principles. She's a frequent speaker, blogger, and panelist on data quality, data governance, logical and physical modeling, data compliance, development methodologies, and social issues in computing. Karen is a Microsoft SQL Server MVP, specializing in data modeling and database design. And if you're not already following her on Twitter, you can do so at @DataChick. Karen, it's great to have you here. Please take it away.
Thank you so much for that bio that I gave you. And I'm so excited again to be speaking with all of you, including the team. I want to thank the team behind all this that makes these sessions happen. I know it's really hard to wrangle speakers, so I really appreciate it. As my introduction talked about, I'm really about the data side of data protection. And in this session today, please do post your questions as you think of them. Don't hold them for the end, because it's always good to see that people either want some more clarification or more detail, and that's always important to see during the session. In this session, I'm going to be talking more about principles and examples. So in my introduction, you noticed that I specialize in Microsoft and Azure data platform related issues. So you'll hear me using a lot of the terminology that comes from the Microsoft side. But of course, because I'm talking about principles and examples, that's just a terminology set. So every data modeler wants you to use consistent language, and therefore you'll hear some Microsoft things, but they really do apply everywhere, no matter what your cloud provider is. I also want to point out that best practices, which is in the title of this presentation, they're really contextual. So I think over the years, we've kind of abused this term of best practices. It doesn't mean it's only for the best and the most well-funded organizations. It doesn't mean perfection. It means given a set of environments, criteria, compliance issues, this is the best you should be doing. It's not always the right for your context, the right for your funding, but have that in the back of your mind as we talk about these things. I also want to point out as a methodologist that the processes and the people behind any of these technologies are just as important, if not more important, than throwing some technology at a problem. Some other thoughts of Amar is that the best practices, I think, because of my data bias, is that knowing your data and loving your data is sort of the foundational thought you should have as you're making architectural, development, database, any of these decisions. I also believe that it's most important that we secure data at the data first. So the more the data travels, the further it travels, the harder it is to, the more risk surface there is, and the harder it is to protect it. I also think that another spin on best practices is new thinking changes what we think of best practices. So in my bio, I say I've been doing this for 20 plus years. I've actually been doing it for 30 plus years. I just didn't want to come across as too experienced to be talking about this. But new technology and new thinking about things changes what is best. So when I first started working in the development world, the best place and really the only place we could take care of data was in the data store and in application code. Now we've come across decades later and through advances know that there are more places to protect it. We should also make data tamper resistant. I'll talk about that. That availability of data is also a security practice. Yes, Gene Stauffer, a world-renowned security expert from Sirius at Purdue, he has this really pithy quote I love that says something like, the only secure system on the planet is one that is turned off and buried in concrete, and he has a bunch of other snarky things to say about it. I tend to agree with him. We look at reducing risks when it comes to security and making the best investments in security, but if the data is not available to us because it got corrupted and we have no backups and we've never tested our restores, we're not securing that data either. And there's so much more to learn that I can cover in this 50-minute session, and I hope that this inspires you for that. These practices that I'm going to talk about today, I mean, this could be a 5-day course, but I want to focus on a couple of the newer thoughts about data protection, that data security is more newsworthy than ever. Everyone should love their data. That's just my mantra. The cloud offers both new ways of thinking about data security as well as more complexity. And best practices span all cloud offerings, not just ones that I might use the terminology for. The other big gotcha that we get into is, what does the term data protection mean? This is hilarious, because as a data person, I think data protection is keeping the data integrity correct for what it needs to be, that we haven't tampered with the data, that the data quality is good. But of course, most of the terminology in the IT field is generated by vendors and industry analysts, people like me. So sometimes when you come across a product that says it's about data protection, or a white paper, or a blog post, or a session like this, they really mean backups and restores. But sometimes vendors mean it's encrypted so that you can't see the data. Some people mean it's secure against attacks, inadvertent or advertent changes. And then there are about 20 more definitions of data protection. So in this presentation, I'm talking about how do we understand that we can trust the data, that it hasn't been messed with, and that we can continually get access to it. So the most important thing is, you cannot protect data that you don't know what it's about, where it is, why it was collected, what it can be used for. Like, we could go through all kinds of W's about the data. You should have data catalogs. You should do data profiling. Data should be classified, not just at the file level, but at the data item level. And we should also automate as much as the protection. But I'm not going to go into this topic too much, but it is my data mantra that knowing your data and loving your data is the first step to all of this. Don't forget that whatever is a service, whether it's database as a service or storage as a service, is starting to store sensitive data in code more than ever before. So in the past, the most dangerous piece of sensitive data that might have been stored in code was a connection string stored in a script or in the application that might divulge too much authority, where people would hard code in the database name, the connection name, the admin login name, and the admin password. But now that we are doing storage as a service, database as a service, networking as a service, backups as a service, now that we're doing those things, we're storing more and more things in scripts or YAMLs or ARM templates than we ever have before, and yet sometimes we're not taking the time to protect all of that information about our data. So the more as a service that we design things, the more we need to remember to protect those things that define the service. That data in those scripts needs just as much protection as the underlying data. Also, I'm on this sort of little pet rant that software-defined storage or software-defined databases looks more like data-defined. Sure, there's some logic and some implementation, but there's a lot of data and metadata and configuration stored there. So as everything gets softer, meaning software-defined, the more that those unintentional and intentional changes get larger, and that new development practice, such as DevOps, DataOps, all of those things, need us to start thinking about the security of this automation. So my first stop, best practice of data protection, is deploy security at the data level first. That means for me, if you can secure it in the database or in the data persistence layer, do that. The reason you want to do that is that security is enforced with every query, no matter where it comes from. If it's an Excel spreadsheet pointed to a database or a CSV file that's stored elsewhere, that protection applies. If it's application code, if it's Power BI, if it's dashboards as a service, if you apply that security level right in as a native feature of the database, it's protected by the database engine no matter what goes against it. It also means that we don't have a variety of security enforcement with gaps or overlaps, such as when we use only application-driven security. Most modern databases and data stores do this fairly well, and it's better than trying to hand roll your own, say, column-level encryption scheme or row-level security. the database engine people have a much bigger test base, testing in production after it's been deployed for these database level security than you'll ever get. It also means that the enforcement of this security is monitorable and verifiable, which is a new way, one of these newish ways of thinking about security. So some examples, these come from the Microsoft world, but end-to-end encryption, which Microsoft calls always encrypted, which means the data is protected at rest, in transit, in use, and right up until delivery. Data masking, which is a way of obscuring all or parts of the data just as it's being rendered. The benefit for this is that someone like a data architect like me can define what is the best way to mask that data, and because it's deployed in the database, that means that the masking is applied the same way. So the example I always use here is most of us know that the standard safest way to obscure a credit card number is to obscure all but the last 4 digits of the number. And that's not just a random 4 digits. Those are the 4 digits that have the least meaning in a credit card number. Yes, those numbers, the first 4 digits, will tell you what bank, what brand, what credit card offering the credit card number is. And having those 3 pieces of information could go a long way towards social engineering a consumer into thinking that you know what their actual credit card number is, because when they gave you the first 4 numbers, you know what product they have. Row-level security is important. We used to implement row-level security. So an example of row-level security is that I work at an insurance company, and I'm only allowed to see the accounts of the clients assigned to me to handle. I can't go poking around to see what insurance a celebrity has, or my neighbor has, or my boss has, because this level of security is that I can only see those accounts. In the old days, the way we used to do this is by setting up database views or adding my data to a row, and the applications would enforce that. Well, with database living things, if I can point a spreadsheet to it, or if I can use Power BI to get access to that data, I could end up seeing more data than I was allowed to see. So having row-level security, over the decades, I've had to work with developers to develop their sort of roll-your-own row-level security, and we missed lots of edge cases that could happen that would expose it, not only to mention that if anyone had access to the data outside the application, all that security just disappeared. The other is, another typical feature of implementing right at the database level is row-level accesses as opposed to login ID level access. So this would be called like role-based access, which is saying Karen is in the Ontario insurance group and therefore can only see Ontario clients. And when I leave the company, they just remove me from the group, and therefore I can't see any of the other things. If I temporarily have to monitor the California accounts because I'm doing backup for that person while they're on vacation, they can add me to that group, and they don't have to remember to unenroll my account there. They just remove me from the group. Those seem so obvious as a way. We've been approaching Active Directory security like this for decades, but it's only been recently that we can do these sorts of things right in the database access level themselves. So the next best practice. So these are both big buzzwords, but a great way of thinking about security. And these 2 things are confidential computing and zero trust. So confidential computing is a way of protecting data by using both hardware and software related to securing access, from securing access to only the people, applications, and processes that should have access to that. It's typically involved in trusted environments, or TEEs, or in containers. It allows us to protect data at rest, in transit, and now in memory, or in the process of being acted upon. This is secure and isolated environment. Sometimes you'll hear the terms enclaves or secure enclaves used in these things. It's very common in the types of data use cases where high protection is required, such as finance and health, government, especially government, for things like anti-terrorism methods, intelligence, all of those things. So I love my data, so I think all data should be protected this way. But of course, like anything, there are cost, benefit, and risks to deploying this way. It's usually comprised with trusted containers, such as Kubernetes trusted environments, enclave-aware applications, or standing up specialized VMs that also have specialized hardware, such as Intel SGX hardware, that all come together with hardware and software and applications that allow us better security. So in the Azure example, Azure allows you to deploy VMs that have both hardware and the specialized software that is isolated from other tenants. So to borrow from the noisy neighbor paradigm, this means you can't have nosy neighbors, so other tenants operating on the same hardware that could somehow try to breach into your area. It means that the data is encrypted even when it's in use. The other benefit here, not that cloud admins have time for this, but the cloud administrators, like the people at Azure or Google or AWS, can't see the data because it's encrypted and isolated and specially managed. In the Azure confidential computing environment, their big claim here is that you don't change your application or your code. You don't have to do anything special. You deploy your existing code to a confidential computing environment, and now it's protected under this framework. It also includes SQL databases that are deployed with secure enclaves. Under the AWS example, their offerings for confidential computing are branded with Nitro. It's also a combination of hardware and software. It's also protected from cloud admins snooping around. It's protected additionally with AWS system software. The workloads are isolated, and there's no code changes. And if you remember from just the previous slide, those are also the principles on the Azure side, and that's because these vendors are working together to ensure that the confidential computing framework, which is something that all vendors can provide. Another new way of thinking is zero trust. Now, in my own life, I think I've kind of fallen this way with personal relationships, just as an aside. But zero trust means an approach to how you architect, how you design, how you develop, how you test. And it is an architecture, there's an architecture from NIST, which is the U.S. government standards body, that says, unlike in the past, where we have deployed technology and solutions, where we have trust, but we work at blocking out people we shouldn't trust, we deploy things, devices and accounts and resources in a way that no one has access, and we just sort of peel back openings and layers so that people can have access. It's kind of the opposite of traditionally we would deploy something in our environment and we would block it all with a firewall that kept outsiders out and let only a little bit of outsiders in through the firewall. This applies beyond the network. This applies to trusting based on location, based on devices, based on accounts, and protecting things. So from the NIST paper, this is an example of the architecture that you have data access policies, ID management, SIMs that Ian was just talking about. You have threat intelligence, and you policies that all apply around this, and you allow access where it's needed. I wish I could spend a whole hour talking about confidential computing and zero trust, but I'm sure that the best thing that could happen here is if you wanted to know modern cloud data protection best practices, you would go study these things, no matter what your role is, whether you're a dev, a DBA, a data architect, a network engineer. these two things apply to all of our jobs and our responsibilities to have an understanding of these. Let's also switch to another best practice, which is tamper-proofing, another new way of thinking about it. So I can hear a lot of you out there, yeah, blockchain, it's overpromised, it's a buzzword. Well, that's entirely true, but it doesn't mean that there's anything about it that can't be used. So the most exciting difference for me over the last year has been the availability of blockchain-like protections right inside databases. So let's review very quickly on this slide some of the fundamentals of blockchain. Blockchain involves timestamp transactions. Okay, we've always had those. Immutability, which means that once data is written somewhere, it cannot be changed. So this is a different way of approaching data. So in blockchain that's used, a full-blown blockchain environment that has massively distributed nodes that are secured in a confidential computing framework, the files can't be accessed, that's all good. But what's different here about immutability is that there are multiple ways to confirm in a blockchain environment that the data hasn't been changed. And we're going to look at that in a minute. In a full-blown blockchain distribution, distributed, multiply owned nodes is important. And this is different than any sort of security that you've designed for your own internal systems. Yeah, you might have a highly distributed environment for performance reasons or for availability reasons. But in a blockchain environment, highly distributed, multiply owned means that someone, in order to change the data, would not only have to fake out the timestamp and some of the other features we're going to talk about, but they would also have to be able to change multiple servers, multiple nodes, I should say, that are owned and protected by different legal entities, different organizations. That's a huge difference. Each node in this highly distributed, multiply owned framework has blocks inside of them. So you can think of blocks like rows in a database. They're not quite the same, but you could think of them that way, that are chained to others. And they're chained to others, linked to others, not just like we might do in a relational or a network database, but in a way that the values of the data item or the transaction are used to make the links. So if someone were to change the data, the underlying data, none of the links would work, and therefore the chain is broken and it cannot be verified. And those cryptographic hashes that are used to link them are both the protection of the data and the verification of them. So I highly recommend, if you're not familiar with blockchain fundamentals, you go find out more about that. So Oracle Database Systems was the first to offer a feature right inside Oracle called a blockchain table. And that is a table right inside the relational database, Oracle database, that has data in these sort of blocks that are encrypted and validated, and the hashes. So if you look at the box on the left, it has a hash in my simplified data model of #1, then the data, and then it has a #0, which doesn't point to anything. In some implementations, you might have a #1, so it points to itself. And that data then is linked to the second block. You see in the middle square that we have the #1, which is pointing back to the first. That #1 was derived from the actual data inside that row in the table. And the second block is identified by #2, which you then see over in the #3 block on the right. So you can see how if that data were to change, the hashes would change, and they would all of a sudden point to different blocks. Now, someone could go figure all that out. We used to do this in the network world. This is exactly how a network database works. But there's an audit log of both the hashing, the crypto hashing, and the hashes stored away from the database in a mutable data store, so that when you issue a command to verify the data, it compares the hashes in that audit log to the hashes in the blockchain, and if it can't be verified, you know that somehow the data has been tampered with. So this isn't the same as normal data logging, where we've had audit logs or changes to tables or backups of tables. Not only is the data stored with these hashes and the hashing keys, is that there's also a function that you can call at any time that verifies that all the hashes are legit and all the data is linked the way it should be. That's what's different in a blockchain table. Now, Azure SQL DB, which is the cloud version of SQL Server in Azure, has also recently deployed the same concept. They're calling it ledger tables because blockchain is a ledger ultimately. And the difference that they've made, it works very much the same as what I just talked through in Oracle. The difference they've made is that they allow you to have both a ledger database, so you can set up the entire database where every table in it acts as a ledger table or a blockchain table, or you can do it only on specific tables. The other difference they've done is that while Oracle doesn't allow any updates to the blockchain tables, Azure allows you to set up a table or a database to be append only, which means no changes, or to make it appear that the data is updated and that people can update the values in the chain. And those are completely different use cases, by the way. You would want to allow an updatable ledger table for all kinds of different reasons than you'd want to use one that is totally append only. So some key features of Azure ledger tables, like I said, you can set the whole database this way. You can create database digests. You can create these ledger tables, make the table updatable or append only. The immutable storage for those audit logs, what Oracle calls audit logs, can be used to record these things. And it also has the ledger verification, the same thing that I mentioned on the Oracle side. The most important thing to understand and why blockchain is perceived as being overhyped is that blockchain verifies that the data written is the data that you're seeing, or vice versa, that the data you're seeing is the data that was written. But it in no way validates the truthfulness of that data. So I can be a bad guy there holding a bunch of money that I've deposited in the bank. And I can tell a blockchain, I just deposited $10 million into the bank. And that blockchain will say, great, $10 million in your bank account. Woohoo! Go on. But if I only actually gave them 10 million pennies, the blockchain isn't going to know that difference. So a lot of the people who write these blog posts or do these videos on why blockchain is a lie, it is because the blockchain only validates what you told it to. So if you lie to the blockchain and say, my name is Minnie Mouse and I live at Disney World, the blockchain is perfectly happy to say, Karen is Minnie Mouse and she lives at Disney World. So just remember, it's a technology that is really about securing tampering of data, and there are so many great use cases for that. Where it goes wrong is that blockchain isn't a solution to data quality problems or data integrity problems that are introduced outside the database. It's not going to fix that. It's going to happily verify that the chain is fine. Let's always remember another best practice to data protection is that recovery is the goal of doing backups. I cannot tell you how many times people proudly walk me through their backup solution, their backup processes, how it's monitored, how well they know, how they know instantaneously when a backup failed or a backup is overdue. But they can't tell me whether or not any of their backups can be restored. So remember this, backup success is not recovery success. And I tweet and post regularly that we don't need backups at all. We do not need backups. What we need is restores. Yes, in order to restore a backup, you need a backup. But what the business needs is restores. We have also learned through ransomware that an important part of having successful restore is immutability of backups. And there are a couple of ways of making sure this happens. One, you could have an air gap, like no connection between your backups and the production system it backs up. That's one way. The other way is to still have a connection, but have those backups stored in a way that they can't be tampered with, that they can't be encrypted over the top of them, much like some of the other things that we've already talked about as best practices. The other thing that most people aren't aware of is they've made these promises of RPOs and RTOs, restore point objectives and restore time objectives, but they've never tested sort of the physics of how long it would take to restore a 300 terabyte database into a relational database. Sometimes doing a full-blown restore isn't the fastest or the best way to get to resume, to get to your restore point objective. And it's up for you to do the testing and the math to see how long that takes. You might need to have a restore point objective that's based more on replication or failovers or availability groups. You should still have backups and still test your restores. But depending on the cost to the business, doing a full-blown full restore might not be the best or the fastest way to do things. And I'm here to tell you that testing restores often is an important part of protecting data. In this, if you have a beautiful dashboard that shows how long your backups take and what the backup quality is and that they've been verified, your dashboard needs to also include how long it takes to recover, and not just the time till you get a green light next to successful recover, but that the business has tested a restore. I've seen backups run beautifully, restores run beautifully, only to find out that someone forgot to not only back up the database, which they did, but failed to set up a backup job for all the files and blobs that weren't stored in the database but were stored on local storage, and therefore the database came back up online and pointed to files that didn't exist. And to the business user, that was not a successful recovery. The other thing to remember is, I've learned this lesson the hard way, good people can end up doing bad things to your backups and restores. So there are people who have backed up databases or data storage for years, but put a password on it to protect it, and then moved on to another company, and that password was not documented anywhere. There are good people who did bad things because they got caught up in bad times, and therefore, either wanted to sabotage backup or restores, or didn't want to help, or took backups off-site and restored them for competitors. You'll always have to trust people, but verify, and this also should fall under your zero trust thinking. Yes, if you can't trust your admins, you've got bigger problems, but there's a way of monitoring. There are new ways and new thinking on monitoring and alerting for trust but verify. Let's talk a minute about how these best practices might change design and development practices. Well, the biggest change, and theoretically this shouldn't have been a change, it just was a change. Security and privacy and protection thinking needs to happen in all phases of a project, starting with planning and architecture. I have seen so many project plans that call for a security design phase, or something that's well after the database design, the storage design, the data type design, the access control methods. if we're not thinking in confidential computing or zero trust or modern cloud data protection best practices at planning and architecture time, we're either going to have to redo a bunch of work, redo a bunch of architecture, or potentially fail at security again. If you're new into DevOps and data ops and all the other ops that are coming up, I even saw ops the other day, operations ops, which that had me confused. If you're new to that thinking for coding and deployment, you also need to think about securing your DevOps pipelines and your source control so that you can understand what's going on while you're doing the development. I have this prediction. So right now, SQL injection is still listed as one of the top 1 or 2 methods for data breaches. SQL injection, a problem we've known for data protection for decades, that we have automated tools to check for, that there are services you can use to check for SQL injection in your application code, and yet we still continue to deliver code into production that has these vulnerabilities. SQL injection. I think that what's going to rapidly approach and replace that as the #1 data protection issue is going to be people who store live data in an open bucket, say an S3 bucket or an Azure data blob somewhere, and it's not protected. They've put it there usually for dev or test reasons. They want to share it with an offsite contractor. They want to have access when they go to work on at home. Whatever it is they're thinking at the time, they've popped some production data into an open bucket and leave it there, forget to turn it off, and think that just because it was just open there for a few minutes, it's fine. No one knew it was there. That's going to become the #1 way that data breaches are discovered. And we have ways of sharing data, production data, that might be used to diagnose a problem, that people are improperly and in some cases illegally using it for dev test data. We have ways of protecting against that. If you find that your development process is to put production data in some storage blob somewhere for someone to get to it, that stuff has to stop now. We think that once this becomes enough of a problem that cloud providers will start implementing ways of profiling your data to see if there's credit card data or medical images or something unprotected. I can envision that happening. And who wants your cloud provider snooping around in your data just because you put it in an open blob? All of your dev and design test cases should test data protection and security items. If you're currently working at an organization where devs and DBAs are told that's the role of the security team to do security testing, it's time to stand up and say, no, it needs to be part of our development environment. I've also found this new thinking, like inverting trust to be zero trust from trust but firewall. I find it's really hard to think about doing something I've been doing for so long. It's really difficult to change how we do that. I also think it's more important that monitoring for security, vulnerabilities, using the things like I'm most familiar with the offerings that are available in the Azure offerings, so SQL vulnerability assessments, which are available both in Azure and on-prem, but vulnerability assessments where I can ship both my on-prem logs and my cloud logs together and do monitoring about what's going on. I need to be smarter about that. And then the big difference is built-in features that are available now are quite likely to be better at protecting your data than anything that you as the average DBA data architect dev are ever going to be able to come up with on your own and have the time to implement it where you catch all the edge cases. So some thoughts on getting all of these best practices right. Modern monitoring and alerting is key to security, and it's often an afterthought. Most devs and DBAs I work with who are dev DBAs they think that the operations people are responsible for monitoring production systems and alerting on suspicious behaviors or data egress or anything. I think your devs and modern devs and development DBAs should be doing monitoring, alerting, even on the development environments, because so many people use production data in those environments. You should be exploring and using, testing, and implementing the modern features in data stores and databases to do data protection, whether that's always encrypted, row-level security, data masking, ledger tables. That's up to data professionals to do. Remember, here's my contentious statement. You don't need backups at all. You just need restores. Gone are the days of using a bunch of random scripts that we downloaded from some smart blogger's blog to save your data or your job. There's plenty of those scripts out there that do a lot of really cool things. I've written a lot of them. I've shared a lot of them. But I can't trust some person's blog post on doing a vulnerability assessment against your database as the only way that I want to do this type of data protection. But on-prem and cloud security share a lot of the same principles, but they don't always use the same techniques. And that's really a difference between if you're using software as a service, say a database as a service, you're not going to have access to all the features that you have access to in your on-prem version of that database, say SQL Server and Azure DB. And where there are differences, it's usually because deploying something as a service means that the service provider has to restrict access to things like how many files it's saved on, how they're striped across disks, or any of those things. That you share a lot of principles, but you need to make sure that as a developer or a security analyst or a data architect, that you understand where the differences are intentionally different. Data inventory is key to data security. If there's data hanging around, sensitive data hanging around in places that you don't know about, or salespeople have started collecting data, like at one client I worked at, they started collecting pictures of their potential clients' driver's licenses. And they were just saving those on their iPhones. And we didn't know about it till some bright sales guy showed it to us. So having data inventory is really important. Modern data protection requires new thinking. That's my big lessons learned here. Attackers have changed their methods. You have to do this as well. So if you've got management pushing back on not wanting to implement a security feature or monitoring or alerting, use this line. They've changed their methods. We have to change ours. And bad quality data can still be protected, but it's not likely what you wanted. Your data, the data in your system, is actually our data. And so I want you to love it as much as I do. And some bonus tips. Trust everyone, but always cut the deck. This is my favorite quote from Jerry Weinberg. I say trust there with a star because, of course, if you're doing zero trust, don't trust anybody. Many breaches seem to be human errors. Please plan for that. Everyone on your team and in your company will make their first big mistake. Plan for that. That's copying a file from production to dev when they meant to copy it from dev to production. That's running a query without a where clause. That is putting production data in an open bucket. You should plan that people are going to be human and make mistakes. And someone who has made a big mistake is likely to be much better at not doing that afterwards. So if someone has made a big mistake, like accidentally caused a data breach, perhaps think about keeping them because they might be more security thoughtful. Automate as much of the things as you can. Test your automation and secure it. Even the best people do bad things on purpose. Plan for that. Know that your data is only secure as your weakest security practice. that's all I have for today. Again, you can reach out to me on Twitter. I go by Data Chick because I love all things data. I also hang out on Facebook and LinkedIn. If you want to link with me, please let me know you met me here. I'll process that faster. So now, do we have any questions?
We certainly do. And great job on the presentation. So let's get right to the questions. Here's kind of a facetious question from Edgar, if you want to comment on it. Edgar says, so to hack the blockchain, you have to be able to hack time?
Oh, is that it? That is. You would have to be able to update, many nodes all at exactly the same time. You'd have to know how all of it works. You'd have to hack time, bin time, and the good thing is space and time are the same thing. How's that sound?
Okay. Hacking time. All right, next question comes from Hiroyuki. He says, any recommended quality metrics to check out how well data protection is done? Any recommended tools for measuring the data protection?
Oh, wow. What a great idea. That's my new startup. Of course, the answer to that is yes. I personally am a fan of starting with all of these things. That if I've got my workloads in the cloud and my data in the cloud, I want to make sure I utilize all of their features, even if it's an upgrade to my subscription or I need to deploy it. Especially true for monitoring and alerting. And then if that's not meeting my needs, I would look to third-party things that hook in and integrate well with my cloud providers. So I work with both types of things, third-party and new. The fact that I want people to start and deploying these things even during development lends me towards those that are already built into the cloud. But if your company's already using monitoring, alerting, a SAM, any type of framework, then yeah, start there. So again, best practices are dependent upon your environment and context.
Okay, great. Next question from the audience comes from Bidahai. Hope I'm pronouncing that correctly. I apologize if I'm not. And the question reads, well, first of all, very informative. And the question reads, in your experience, where do banks fall short in the design and development of their digital services? Where should we pay particular attention? What advice do you have?
I could go on stories at my own banks. Big it depends. But I'm thinking that the most important thing is that you follow whatever compliance and security frameworks that are targeted at your own industry. Finance, health, government, it's so important that you focus on meeting the best practices and regulations for your industry first, and then look at the more general compliance things.
Okay, next question comes from Mohammed. He's got some acronyms in his question. Does CASB, which is Cloud Access Security Broker, or CASB and DLP, Data Loss Prevention Software, are good sources depend on data at rest and data in motion?
So I'm most familiar with data loss prevention type approaches. And so are good sources? Yes, they are good sources. But I think the new thinking that I talked about, because you've mentioned data at rest and data in motion, is that, now we're thinking about how to secure data in all three of the states, like data at rest, data in motion, data in use. And that's what's going to come together to kind of truly protect data in all of the places it is. So another big it depends. I apologize. Are you there?
Yeah, sorry about that.
Sorry.
Once every session, I I have to put myself on mute and then forget about it.
Oh, yeah.
The next question in the Q&A box reads, we only allow the application to access the database so we can put the data protection in the application, right?
Well, that will certainly protect the data that your application has access to, as well as one type of use of the data. But it in no way protects the data fully. So it doesn't protect data that the application has no access to, which actually does happen. It only protects the use of data that's accessed via that application. And we know that modern IT, has started opening up all kinds of ways that data is accessed. So data going from, being taken out of your transactional database to make its way to the warehouse or to analytics isn't going to be protected by your application. So that's the old way of thinking, not the modern way of thinking.
Okay, it looks like we have time for one more question. And here it is. We have a security team responsible for testing security, so they have their own test cases. Isn't that good enough?
I certainly still want to have security, laser-focused people testing data and applications and networks and everything. But I think, as I said in the slides, it's time for everyone in IT. So security by design, security by architecture. We start thinking we should totally invert how we think about building systems. We should start first with assuming everyone on our team is out to hack us. Everyone outside, including my own mother and my cats, are going to attack the system, and start designing there and just build in, not the formal zero trust framework, whatever buzzword, but just build every single thing, assuming that there are bad actors. So much of our IT, our systems were developed assuming everyone's a good person. If you think way back to how email was developed, it just assumed people would use it only for good things, like sharing cat pictures and recipes and booking meetings that should have been handled in email. And now we know, decades later, that it's a constant fight to keep people from abusing email. And therefore, we need to design our data and our systems that starts out with all the ways it could be compromised, tampered with, and ransomware, and work out from there.
Okay. Cat hacking, another threat we have to worry about.
Yeah.
All right, that's all the questions we have. So thanks again, Karen, for a great presentation and answering those questions.
Thank you. Thank you for having me. I hope everyone goes out and studies more about how to be more secure.
Okay. Now I'm going to pass things off to McKenna for some closing remarks and to announce the winner of the iPad Pro. McKenna?
Thanks, David. Hi, everyone. We want to thank you so much for attending today. As you leave, you will be asked to take a short survey with your opinions of this event. Please be sure to put in your honest opinions. Our editors read every answer you submit, and they really use your feedback to shape our future events and to give you what you want. And speaking of our future events, we really want to thank today's sponsor, Rubrik. They're sponsoring this event because they believe in this community and want to support events like these. So please show your support and appreciation by contacting them for a demo. The link for that is located in your audience console under the resources section. It's through their underwriting of these events that we can bring more summits in the future. So please do click that link for the demo. So thank you so much to Rubrik, our speakers, and our fellow moderators. And now it is time to announce the winner of our iPad Pro. So let me pull it up right now. A big congratulations to Marshall Taylor from RIA Medical Group. You have won the iPad Pro. Our team will be in touch with you this week on how to claim your prize, so please keep an eye out for that. And that wraps up our summit for today, everyone. Thank you all so much for joining. You will get a replay email within the next few days to watch the presentation on demand or share it with a colleague. We really hope you enjoyed this event. Please, like I said, be sure to take the survey that pops up when you exit. And thank you again to our wonderful sponsor, Rubrik. Have a wonderful rest of your day, and we will see you next time.